Okay, let's go through solving equations, maybe one or two different ways. So first of all, what do I mean when I say let's solve an equation? So we could say that's an equation, and when we're going to solve it, we're looking for what does x equal to. So algebraic equations will have variables in them, and when we say we're trying to solve it, we're trying to find out what possible value that variable could equal. So this one we can we could just use some reasoning, some logic. 3 times something is equal to 12. So that means that something would have to be 4. And that's just from our math facts that we know 3 times 4 is 12. Another example could be if we have x plus 2 is equal to 8. Again, we could use reasoning. Something plus 2 is 8. That means that something would have to be 6. That just comes, again, from our math facts. We know 6 plus 2 is 8. There's other ways to think about this as well. Let's come back to 3. I'm going to say 3 times x is equal to 12. Another way to think of that is like x times 3 is equal to 12. It's the same thing. And the idea is, well, if I had some number and I multiplied it by 3, to undo it, I would divide by 3. So if I divide 12 by 3, I get x is equal to 4. So that's undoing the operation. I'm going back this way. I'm undoing the times 3. The example with this x plus 2. If I want to undo the plus 2, it's a minus 2. That undoes that. So we get x is equal to 6. So that's kind of like the formal, kind of like applying some rules in our, I guess, some math rules to say how we got 6 in that one, as opposed to just reasoning. We know that it's 6. So we can undo equations. And we could do a more complicated one. We could have something like 2x plus 4 is equal to 10. So the first thing I can undo that. This is my own notation, like that little arrow thing. There's nothing special about it. I'm going to undo the plus 4 by subtract 4. So I'm going to get 2x is equal to 10 minus 4. That's 6. So now I have a new equation. It's 2x equals 6. And now I can undo the times 2 by divide 2. So if I go 6 divided by 2, I get x is equal to 3. So that's this idea of undoing. So that's one way to explain how to solve for an equation. We can also do it using this idea of algebra tiles, and it's a little bit awkward. Like, it's much easier if you actually have the tiles in front of you. I don't have tiles right now. Let's suppose I draw a bunch of squares. I'm going to say each square is worth 1. And I'm going to draw some rectangles, and each rectangle is worth an x. And I could also draw some similar triangles, but say if they're colored red, maybe that's a negative x. This one's a positive x. These are positive ones. And that would be a negative 1. So we just have some pictures, some shapes that represent values. And we can represent an equation by doing this. So the equation I had earlier is 2x plus 4 is equal to 10. So I can, it's nice, again, it's nicer to have tiles, but I could kind of draw this out. If I have 2 x's, it means I have one of these long, kind of skinny long rectangles, white, and 2 of them. So I'm going to have 2 of those. And I'm going to have 4 of these squares. Everything's positive, so I don't have to do any coloring. And then on this side, I have 10 of those squares. So that's 6, 7, 8, 9, 10. Okay, so this drawing models or represents that equation. Okay, now the idea is, like, I eventually want to get to something that says x equals. That's what it means to solve something. So I want all the rectangles on this side, on the left side, and I want all the squares on this side. So That's kind of the goal. That's what I'm going to try to do. I'm going to try to move things around and do that. Now, I can't just like, oh, I'm just going to move all these over here and I'm just going to like have 2 rectangles equal to, and then I draw like 14 things. Like that's not a thing. That's like saying, oh, this is supposed to be 4. That'd be like saying 2x. So we know 2x plus 4. We know x is going to be equal to 3. I can't just go, well, instead of putting the 4s on this side, I'm going to move them to the right side. So I just want to move them over. I'll go 2x. So that's 2x equals 14. And we know, just using our logic, if 2x equals 14, x equals 7. That is not true. That is obviously not the same thing as that. We can't just move stuff around. We have to use mathematical rules to do this. So what we can do, and the idea, I guess, is, or a helping idea is this idea of a balance. If you have like a beam, like a teeter-totter, something's balanced. If I add something to this side and I add the same thing to this side, that thing stays balanced. And this is kind of the model that we use for this, for algebra tiles. If I add a white square to the left side of the balance or the equation, I have to add a white square to the right side. It keeps things balanced. Alternatively, if I add, say, 2 red things to the left side, I have to have 2 red things on the right side. And if I do that, it stays balanced. So that's kind of the principle we can use to continue using algebra tiles to model solving an equation. So we're back to this equation. So we're back to here. We have 2x plus 4 equals 10. And my suggestion is, well, I'm going to add 4 red tiles to that side. And if I add 4 red tiles to that side, I have to add 4 red tiles to this side to keep it balanced. And that's kind of what I was doing over here. I said on this balance beam, if I add 2 red tiles to the left, I have to add 2 red tiles to the right. So that's what I did here. Added 4 red tiles on the left and 4 red tiles on the right. That keeps everything balanced. And when I do that, some of these cancel out. If you have plus 1, if you have a 1 plus a negative 1, that cancels out. That's 0. 1 and negative 1 cancels out. 1, negative 1 cancels out. 1, negative 1 cancels out. Yeah. So all those cancel out. And you can also, I could write this down as like plus 1, plus 1, plus 1, plus 1, minus 1, minus 1, minus 1, minus 1. That's equal to 0. So that's the idea of canceling out. If you have a plus 1, if you add a negative 1, they add up to 0. And the same goes for over here. Those 2 will cancel out. Those 2 cancel out. Those 2 cancel out. And these 2 cancel out. Those all add. If you add up all those things, you get 0. So we can now redraw our equation. So we have 1x, 2x is equal to, and I have 6 blocks on the right hand side, 6 squares. So now it's great. I have all my x's on one side. So now I'm kind of ready to say x equals something, and we can see how that proportion works out. You can kind of see here that each x is the same as 3 squares. So x equals 3. So that's using algebra tiles. Okay, so let's do another one, and I'll just kind of sequence and model solving an equation without any kind of diversions. So let's try 4x minus 6 equals, let's say 2. So first of all, I'm going to draw all these things. So there's my 4x. And my negative 6. So I got to draw 6 squares. But I have to call them red because I'm keeping All my negatives will be red, so I'll color those. Okay, that's equal to 2 squares. So my shapes now model the equation. Now I'm going to rearrange the shapes to solve the equation. So I want, once again, I want all the x's on one side because I'm hoping to have something that says x equals, or rectangles equals, something like this. So I want to move these red squares to the right. So how do I do this? I can't just move them, but what I can do is I can add equal amounts of the same thing to both sides. So if I add a white square there, I have to add a white square there. Add a white square there, 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 a couple more. They don't look like squares, but they're squares. Okay. Those things cancel out. Cancel, 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 cancel. All those are equal to 0. So I'm left with four rectangles. So 4x's equal to, and I have 8 things on this side. 5, 6, 7. So the next question is just to kind of show another little thing here. 4x is equal to 8. I can redraw this to make it kind of more obvious what each one of those is equal to. I'm going to move those 2 there, 2 there, 2 there, and 2 there. And then I will erase so I still have 8. I'm just kind of drawing it slightly different to kind of hopefully better show how that x is 2, this x is 2, 2. So each one of these x's is 2. So x equals 2. And we can plug that back into our original equation to see if it makes sense. So 4 times x minus 6 is equal to 2. So I said x is equal to 2, so I'm going to do that. So 4 times 2 is 8. 8 minus 6 is 2. Check. That works. That makes sense. So that's how you can use algebra tiles to model an equation. And one other thought about this is I have 4 x's on this side, and I have 8 things there. It's kind of like I want to divide, because I want each x, because there's 4 x's, I want to divide all of these into 4 equal groups. And when I do that, I get x is equal to 8 divided by 4 equal groups, which is equal to 2. So, and it's also just like this idea, 4x equals 8. If I want to undo that operation, I would say x is equal to 8 divided by 4. That's the understanding for that. Okay, so that's using algebra tiles to model solving an equation.